Hello everyone, welcome to another kinetic tutoring episode. Today we're looking at another AP test problem, or rather a problem from the AP College Board. This problem has to do with forces, and it also involves differential equations, so let's get straight into it. The prompt reads, a skier of mass m is skiing down a frictionless hill that makes an angle theta with the horizontal as shown in the diagram. The skier starts from rest at time t is 0 and is subject to a velocity-dependent drag force due to air resistance of the form F equals negative bv, where v is the velocity of the skier and b is a positive constant. Express all algebraic answers in terms of m, b, theta, and fundamental constants. So let's take a look at part A. Part A reads, on the dot below that represents a skier, draw a free body diagram indicating and labeling all the forces that act on the skier while the skier descends the hill. Alright guys, so let's start with our basic forces. We know we have gravity, as always, and it is pointing downwards. We have our normal force, which is going to be perpendicular to the horizontal. And our final force is the force of air resistance that the prompt talks about. We have F air. And now let's take a look at part B. Write a differential equation that can be used to solve for the velocity of the skier as a function of time. So the first thing we want to do, guys, is take a look at the net forces. We can see here we have a free body diagram of the forces. So let's write out all the forces that are acting on this block, or on the skier, in the x direction. So here we see that the n is going to be acting strictly in the y direction, in the vertical direction. And we see here that let's draw our free body diagram a little bit bigger here. Have n, have mg, and we have air resistance. N is going to be strictly vertical. Mg is going to have a horizontal component alongside a vertical component, and our air resistance is going to be strictly horizontal. So our net force in the x direction, and we know that we can always write our net force when we're talking about translational motion as ma, is going to be the horizontal component of mg, which is just mg sine theta, minus the force of air resistance, which we're given as bv. So here we go. Here is our force equation, and we want our differential equation which we're going to derive from here. This is pretty simple. You just have to remember that your acceleration can be written as your change in velocity over your change in time, m dv dt, and then rewrite everything you have on the other side. And from here, our last step is just to get this dv dt by itself, and to do that we're going to divide both sides by m, and we'll get that dv dt is g sine theta minus bv over m. Here we go. There's part A and part B complete. Now let's move on to the next sections. Alright, now they want us to determine a terminal velocity for the skier. So we know that our net force in the x direction was mg sine theta minus bv, and we know that terminal velocity is reached when the particle is at its maximum speed, or the object is at its maximum speed, meaning that it is no longer accelerating. So we can write our acceleration as 0. So our mg sine theta minus bv is going to be equal to 0. And from here, what we're going to do is move the bv over to the other side. Get that bv is equal to mg sine theta. And since we're solving for velocity, we divide both sides by b, and we'll get that our terminal velocity is mg sine theta over the constant b. Now let's take a look at part D. Solve the differential equation in part B to determine the velocity of the skier as a function of time, showing all your steps. So guys, let's rewrite our differential equation. We had dv dt is equal to g sine theta minus bv over m. From here, we're going to want to get our dv and our v on the same side and our t on the other side. So we'll get dv over g sine theta minus bv over m is equal to dt, and then we're going to integrate both sides. From here we can do a u sub. We'll say that we'll call this bottom term here our u, and that'll give us a du. When we take the derivative here, we know g sine theta, sine of theta and g are both constants, and the derivative of a constant is 0, and the derivative of negative bv over m is just going to be negative b over m dv, because both b and m are constants. So from here we have our dv, we're missing our negative b over m, but since both of these are constants, you can just multiply by the inverse of that on the outside, negative m over b, integral of du over u is equal to integral of dt, which is just t plus c. So let me just erase this to create more space. Had negative m over b, integral of du over u is equal to t plus c. Keep in mind that our u is g sine theta plus mv over b, or sorry, rather bv over m, and it was a minus, I believe, minus bv over m. So we know that du over u will just give us natural log of u, so we get negative m over b, natural log of g sine theta minus bv over m will give us t plus c. And from here we want to solve for our velocity as a function of time. So what we're going to do from here is multiply, firstly we're going to multiply both sides by negative b over m to get ln g sine theta minus bv over m. That'll give us negative b over mt plus c, because our constant multiplied by two other constants is just going to be another constant. And then from here we'll put this to the e, which will give us g sine theta minus bv over m, e to the power of negative b over m t plus c. And due to our log properties, we know that, and power properties, we know that we can bring this c down over here. So we'll get that g sine theta minus bv over m is equal to c e to the negative b m over t, b over mt. I'm going to erase the top again just to create some more room. Here we go. Let's start back up from here. What we're gonna do is subtract g sine theta from both sides from here. We'll get negative bv over m is equal to c e to the negative bm over t, or bt over m, minus g sine theta. And our final step is going to be to multiply by negative b over m, and by doing so we'll get v is equal to m over b g sine theta minus c e to the negative b over mt. Here we go. Here is our final equation that we get from differentiating. And our final step is just going to be to solve for our value of c. And the way we're going to do this is because in part 1 of our equation, it's stated that the skier starts at rest, meaning at v is 0, when t is at 0, v is also at 0. So let's plug that into our equation. So we'll get that c e to the 0 is just c, so 0 is equal to m b g sine theta minus c. And therefore our c is going to be equal to g sine theta. So you're just going to have to plug in the c into this equation here. So, and when you do that, you'll get mb, you can take out this g sine theta, and you get 1 minus, let me just write it out actually. Alright, so keeping in mind that our c is going to be equal to g sine theta, we'll get that our v is mb g sine theta 1 minus e to the negative b over mt. There we go, and that would be your final answer for this part D of this problem. And now let's take a look at the last part, part E. On the axis below, sketch a graph of the acceleration a of the skier as a function of time t, and indicate the initial value of a. Take downhill as positive. So let's write out our force equation that we had initially. We had ma is equal to mg sine theta minus bv. We know that our initial value of a is our a at t0. We know, and the way we're going to find this is by plugging in v is 0, because we know that at time t0 our velocity is also 0. So ma is mg sine theta. So our acceleration starts at g sine theta. So we can draw a point here and say that our point g sine theta is where the acceleration starts at, and we know that it is reaching terminal velocity, and as it is reaching terminal velocity our acceleration is decreasing, so we are slowly approaching 0 as time progresses. And so there is how you would draw that graph. There you go, guys. I hope that helped. That's all I have for you today, and make sure to subscribe and tune in later for more physics tutorials.